Hello. In this video, we're going to go ahead and look at the limits at infinity. For any positive real number n, the limit as x goes to infinity of 1 over x to the nth power equals 0, and the limit as x goes to negative infinity of 1 over x to the nth power is also equal to 0. Now what this tells me though is that if n is positive, we also have this, the limit as x goes to infinity, or negative infinity, either one, of x to the negative n power is also going to be 0. And the reason why is because this is just this. That's what a negative exponent does. It just flips it to the other side. Alrighty. So, for finding the limits at infinity, if f of x equals p of x divided by q of x for polynomials p of x and q of x, and we know the fact that q of x is not equal to 0, then the limit as x goes to negative infinity of f of x and the limit as x goes to positive infinity can be found by doing the following. First, divide p of x and q of x by the highest power of x in q of x. In other words, divide every term by the highest degree in the denominator. Number 2, use the rules for limits, including the rules for limits at infinity, to find the limit of the result from step 1. Alrighty, so let's look at this. We have an example here. We want to find the limit as x goes to infinity of 8x plus 6 over 3x minus 1. Now then, to do this, we first need to look at the denominator. Now in the denominator, notice that we have x to the first power there. And so since we have x to the first power there, we need to divide every term that you see in here, here, and here, by x to the first power. Never include the coefficient, just the variable with the exponent. So when we do this, this is going to give us the limit as x goes to infinity of 8x over x plus 6 over x, then all over 3x over x minus 1 over x, and then just simplify. Doing so gives us the following. We have the limit as x goes to infinity of 8 plus 6 over x all over, and then in the denominator we have 3 minus 1 over x. And technically what we're about to do here is we're going to distribute the limit to every term that you see in there, and it would look like this. You would have the limit as x goes to infinity of the number 8 plus the limit as x goes to infinity of the number of 6 over x all over the limit as x goes to infinity of 3, then minus the limit as x goes to infinity of 1 over x. Good. Now technically the 6 can go up front and there's already a 1 there. It's not a big deal though. What this is telling me is as long as x goes to infinity, this all goes to 0. And as long as this goes to infinity, this all goes to 0 as well. So that's 0, and we're left with 8 and 3 here. So that's pretty much it. Just simplify. We have 8 plus 0 over 3 minus 0. And then that just simplifies to 8/3. And there you go. That's pretty much it. Alrighty. Well, I think I'm going to go ahead and leave it here, and I will see you in the next video. Have fun.